Let's talk about how we graph a cubic function of the form y equals ax cubed. So let's actually start with the simplest cubic function, and this should be to the third power here. So just the very simplest cubic function is x to the third. So I want to start by making a t-chart here. So I put in some x values and I want to find out what the y values will be for those. So if we take -2 to the third power, we'll get 2 to the third power, which is 8, but it'll be negative because a negative times a negative times a negative is still negative. So this will be -8. -1 to the third power is just -1 because all those ones multiplied are still 1, and the negative stays. 0 to the third power is just 0. 1 to the third power is 1, and 2 to the third power is 8. So if we plot that, here we have 0, 0, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 2, 8, -1, 1, and -1, -1, and then -2, -8. So if we connect that, this isn't going to be super good. Oops, let's try that again. Just doing the best I can here. Okay, that was pretty good. That dot's not quite there. So this is what a cubic function looks like. This is y equals x to the third power. Okay. And you'll notice that this is an odd function. We learned in a previous video about even and odd functions, and this one's odd because if you imagine turning it around, flipping it around 180 degrees, it will look the same. We also know that it has only odd powers of x, so by the equation it should be an even or an odd function as well. So now let's talk about if we have a function that has some coefficient in front of it. So like y equals 2x to the third power. So this is just going to stretch out this graph a little bit. So let's go ahead and make a chart and take a look. So this time I'm just going to put -1, 0, and 1 on. Well, I'll go ahead and put 2 also, but I don't think it's going to be on my graph. So x to the third is going to be -1 times 2 is going to be -2. 0 times anything is still 0. 1 to the third is 1 times 2 is 2. 2 to the third is 8 times 2 is 16. So like I said, those points are not going to be on the graph. So I have 0, 0, 1, 2, and then 2, 16. So we know it's going way up. And so 2x to the third is going to look something like that. And so you can see it's being stretched vertically, and stretching it vertically makes it also look skinnier. It's not really getting skinnier per se, it's just getting stretched taller. But as you stretch something taller, like think about a funny house mirror, when you have a mirror that stretches something really tall, it also makes it look thinner. Okay, let's try one more. Let's find a different color. So let's try y equals -1/2 x to the third. So let's go ahead and make a chart. So if we put in -2, -1, 0, 1, and 2. So here we have -2 to the third power is -8 times, so -1/2 times -8 should be +4. Here, negative 1 to the third power is negative 1 times negative 1/2 is positive 1/2. 0 times anything is 0. 1 to the third is just 1, so it's going to be negative 1/2. And then 2 to the third is 8, and negative 1/2 of that is negative 4. So if we have a negative multiplier, it's going to flip everything around. So here we have negative 2, 4. We have negative 1, 1/2, 0, 0, 1, negative 1/2, and then 2, negative 4. So it's going to look, oops. All right, one more try. Okay, so it's going to look something like this. So if there's a negative in front, it's going to switch so that it's going from the second quadrant to the fourth quadrant instead of the first and the third. And when we have a half in front, it's going to make it shorter and fatter, whereas having a 2 in front made it taller and skinnier. But basically, any cubic function of the form ax to the third has some general shape like this, kind of a squiggle. And it's going to always have that same shape, but it will be stretched or compressed depending on the number, the coefficient that's in front of x to the third. And that's how you graph a cubic function of the form y equals ax to the third.